Okay, good evening everybody. Okay, today's topic here we are looking at will be on power. Okay, the question that we are using here today, okay, has several key things that I would like students to actually remember or to take note actually. Okay, based on this question here, the story is about like a girl is doing exercise, a step up exercise. Okay, after that the question will evolve to ask the students what is the gravitational potential energy, and eventually end off with asking for the average power for the girl. Okay, before we look at the question, okay, same as before, let's analyze the question first. Okay, the mass of the girl given is 60 kg. Okay, 60 kg. Okay, after that the top of the box is actually 30 cm. Okay, same thing here we are looking out for is in terms of the values given. 30 cm, take note, okay, try to change this to SI unit first. Okay, be it whatever formula you are anticipating, whatever topics that we are anticipating we are using, most of the concept that we're using, or most of the mathematical manipulations we are looking for is actually in terms of SI units. So this particular value here you need to change to 0.30 meter, okay, above the ground, and after he step up for 150 times. Here need to be careful. Okay, this is one of the unique thing. We have 150 times here, so we don't know what it's going to be used for, but just take note, okay, for the 150. And then this exercise was done in 5 minutes. Okay, 5 minutes. Okay, in terms same as before, 5 minutes for time. We always use time actually in seconds. So take note is that if you look at time, the possible values that we need to handle is actually 5 minutes, but we need to measure in terms of seconds. So students, we need to like subconsciously make sure that we actually convert this to seconds. Okay, in your whole syllabus for O level, for time, unless otherwise stated, most of the time we always use in seconds. Only one formula we actually convert to power. That's when we look at electrical energy, when we look at costing, where we use the unit kilowatt hour. Okay, but that's for a later date. But for now, okay, common thing I always remind myself is that height or distance is always in meter, mass is always in kg, and time is always in seconds. Okay, and gravitational field strength is 10 Newton per kg. So once you are here, roughly we are ready to start or to look at the questions. Okay, the questions look at asking for the gravitational potential energy when the girl actually climb up the steps. Okay, when he climb up, he actually raise the whole body up by actually 30 cm. Okay, so simple thing would be raising height. Raising height will give a raise in increase in gravitational potential energy. So the formula we are looking out for will be simple mgh. Take note, mgh, same thing, h must be in SI unit, mass must be in kg. So make sure all these three variables that you have are in the correct units. After that, substitute them inside, and you actually get the answer that you actually required, which is 180 joules. Okay. The second part that we're looking out for is actually average power. Okay, average power here. Okay, things to appreciate is that the marker actually uses the word average. Okay, why average here? Okay, why do we use average? Is one of the primary reason I believe is that because the girl did the exercise for 150 times, each time the energy span or the time taken for each of the step up is actually not the same. So it's actually quite difficult to find the power for the girl for each of the step up that she did. So if you do 150, it's actually possible to look at it one by one. After that, once you get the power of individual exercise, then after that you add up, you find the average. You can do some manipulations to look for the average power. Okay, so usually for O level we look at it in terms of as a whole. So instead of looking at asking students to find the individual power of each setup, we actually simplify the scenario to say asking it for the average. So we are not looking at whether is each of the sessions same or not the same, or what was the exact number for each of the step up. Okay, because it's like mathematically it's quite tough actually to look at it individually. So we just group it as a whole, like 150. Oh, I just want a single number, a single manipulation. So I look at it as an average. Okay, so the good thing about average is actually the formula actually is simplify the formula. Okay, so the formula that we are looking out for is same energy over time, but the energy that we are looking out for here is the total energy I need for actually 150 times. Okay, and the time taken here I need is actually the total time I need to complete the 150 sets of exercise. Okay, for time it's quite straightforward because the question actually mentioned it is actually 5 minutes. So the only hurdle that students will actually have is actually converting it to seconds. So take note, this one, the time you need to convert to second. That's what I did here for the working. Okay, 5 times 60. Okay, which I convert 1 minute is 60 seconds. Okay, then after that I multiply by 5 because it's 5 minutes. Energy I use for energy. Part A already found. Okay, your energy use is mgh is 180. Okay, 180 joules. Okay, 180 joules is 1 step up. So if I did it for 150 times, I need to multiply by 150 times. Okay, so that's where the numerator work out this way, and you eventually end up with the manipulated answer to be 90 watts. Okay, this will be the average power of the girl itself. Okay, standard things you have is like SI units. Okay, the units for the thing, and the answer limit is 2 or 3 SF. Okay, now things to take note is like the idea behind this question, like I mentioned before, I can't really look at it as individual power because I will not know what is the time taken for each step. Because although the girl did 150 steps, but it doesn't mean that each step is actually completed in the exact timing. Okay. The other things to take note is that in these whole questions, there is one assumption, one simple assumption, or the common assumption here that we're looking out for is that, okay, the work done, okay, the loss in energy when the girl stepping down, all these things, or even stepping up, the loss in energy is actually negligible. Okay, so simple energy, lost energy level, it could be in terms of sweating, it could be in terms of heat loss to the environment through sweat, all these things, or it could be simple thing like heat loss at the friction when the girl push herself up. There could be frictions, or there could be additional exertion of energy. All these are actually neglected. We just assume it to be 0 to have an ideal case. So at least we know what is the ideal scenario, what is the best to benchmark the particular situations. Okay, so it will give us a good benchmark or ideal number to work with at the beginning. Okay, so the idea of me using this question as for power, two primary reasons is to actually explain to students, okay, the idea of using average, why I can't calculate the power for each of the setup, and the second reason I use this question is actually the use of the units for these questions. Okay, because the units used in this question are common units like what, minutes, cm, which we use it quite common in real life. But if you look at it in terms of theory, in terms of your calculations on paper, okay, it's actually slightly different. Because on paper, on theory, we're looking at SI units. So the units that we use, okay, are somewhat actually a bit of inconvenience. So we just students need to remember to convert them before using it, okay, for their calculations. Okay, and if you fail to do the conversion, it will actually end up quite badly done. Okay, even though the concept is correct, the only mistake you make is you forgot the conversion. But of course, the answer is wrong. Okay, the meaning that you are trying to show to the marker actually will illustrate that you are actually confused. You do not know what are the important things to take note. Okay, so bear in mind these are the two things that is important. Because if you look at it as a student point of view, as a teacher point of view, and the idea of me, the examiner, setting up a question is actually to assess the student's competency in handling the data and handling the concept. Okay, so for power, I would say it's a straightforward issue. If you still have problem, okay, feel free to look at my video on power, which I believe is 6.3. Okay, if my video is unclear or you have problem relating the topic to previous segment, okay, just feel free to drop me an email or just WhatsApp me, okay, so that I can actually improve on my videos, or actually to use further examples to show some clarities or to share some clarities on understanding, or even your feedback is actually important for me to actually improve, okay, on the way I teach and on the way the video is being crafted out. Okay, if not, okay, that's all for the night. Okay, okay, Good night, everybody. See you.